Hi.
Hi, my name's Graham Clark. I'm the product marketing engineer here at Renesas, and I'm currently on our booth introducing our new RA4L1, which is a new low-power 32-bit microcontroller based on the CM33 core.
Low power.
These devices are aimed at a multitude of applications, some of which we're actually showing here on the stand. This, for instance, is a demonstration of smart lock. One of the key features that we're seeing customers request today is low power consumption, but also security. Because of the new cyber regulations that are coming, security is becoming more and more important. So this is just a typical application where you can see the benefit of implementing detailed security functionality onto a low power device. So this is a simple smart lock, as you might find inside an hotel door. So here we have a key. Typically, for instance, for somebody housekeeping, they'll come, use the key, and open the door.
How low power is it?
So this device will take as little as 2 microamps in standby mode. So
2 microamps, and it's ready to get an NFC wake up.
It'll waken up there at actually about 1.6 microamps probably.
So that means there could be something here that really runs for 3 years on a little battery
on a small
or something?
battery. That's the whole idea. If you have a hotel full of hundreds of rooms, you don't want to be going around and replacing the battery every day.
All right. Is this the best in class for this performance per watt?
This is a good benefit. I mean, there are lower power devices from Renesas and other people, some of our competitor. The nice thing about this is it's really the good balanced mix of functionality in terms of low power consumption, security, and features.
What more you can talk about here?
Sure. So this is a block diagram of the device. Here you can see it's an 80 megahertz Cortex-M33.
Sorry, one second.
Nope.
Sorry. So let's say again. So what can you show here on the screen?
So this is the block diagram of the device. This is the RA4L1. It's an 80 megahertz Cortex-M33 with 256K times 2, so dual bank flash, which supports software updates and over-the-air updates if you want. It has 64K of SRAM and 8K of data flash, where you can use an E2 PROM replacement. We have a lot of different functionality, lots of different types of serial interface, low power UARTs, I2C and I3C interfaces, CAN FD, USB full speed, a lot of good communication interfaces supporting lots of different applications. A lot of system features like on-chip oscillators, DMA and DTC control, a lot of analog functionality, lots of timers, but probably most important is all the security features. This device has a unique security engine implemented in this device, and it supports a unique ID, a hardware root key, random number generator, acceleration for ECC and AES, as well as all the key management functionality. So it's a very powerful device with a lot of security features in it, but low power consumption.
How do you design something with so much security and such a low power?
So we provide a lot of support for customers to actually use this device in terms of tools, both in terms of our FSP, a software library with all the high-level functions that people can use to run on the hardware of this device, along with tools to support that as well. We also have an environment where you can actually generate and use keys with this device to help you build your prototypes.
And what are you showing here?
So we have some other demos as well. So for instance, this device supports our CapTouch environment and has some dedicated CapTouch keys. So you can actually see we have some CapTouch pins, we have some wheel. You can configure the device to support both mutual and self-capacitance, and you can have up to 12 channels of capacitive touch key. So when combined with the LCD display, it makes it very easy to make a variety of different user interfaces.
So it's like a standby ready for touch?
Yep, absolutely. So you can actually use this as a power on switch. So very low power consumption, touch the switch, the device powers up.
And there's all these scenarios of kind of like standby things, right?
Yes.
And then you could potentially trigger other SoCs or
you could
microcontrollers.
Absolutely. And we've also got a lot of special low power features in this device, which allows you to create events in the device themselves, which can operate without the CPU. And you can use the timers to trigger the serial port. You can use the timers to trigger the A to D to trigger messages being sent out, all without CPU intervention. So a lot of quite interesting features in this device to support low power.
And what's on this one?
And finally, we have another typical application. Metering is a very big application area for Renesas. So here we have a typical design of a water meter based on a wheel. So we can turn the wheel and you'll see the numbers increment or decrement. It uses an inductive sensor with some of our timers just to measure the position of the wheel and the direction of travel.
How is it possible to fit all these different scenarios in one chip? It has to be designed from the beginning?
It has to be designed
or there's
from the
way
beginning.
to add things?
Yep, so we try and put as much functionality in this chip for as many different types of low power application as possible, so we can make a very cost effective device that will have high volume and allow everyone to take the benefit of the technology and a good price.
Is it in mass production?
It's literally just started mass production now. So mass production started just after Christmas.
All right, and it's going to be a big market, you think?
Oh, it already is. In Europe, one of the major markets for this type of device, Renesas sell many millions of similar products based on older technology today. So we expect this to be very popular here in Europe.
Did you have a lot of discussions here at the Embedded World?
We've been very busy so far.